In recent times, you must have definitely heard about the James Webb Space Telescope. If you haven't already, do check out our previous videos to learn about the incredible discoveries made by this exploration powerhouse. You will find the links for the same in the description below. So here we have an engineering marvel that signifies decades of research and development with the sole purpose of expanding our knowledge of the universe. After years of delay and billions of dollars spent, the telescope has finally reached its observing point, Lagrange Point 2, an area in space 1 million miles away from the Earth. The telescope took 30 days to get there, but even before it left the ground, James Webb Telescope went through a long journey that perhaps you must be keen to know. Welcome to Space Nomad, and in this episode, let us understand the construction and transportation of the James Webb Space Telescope to finally become an eyepiece to the undiscovered, unknown, and unimagined. Construction of JWST. Discussions of a Hubble follow-on started all the way back in the 1980s, but serious planning began in the early 90s. The High-Z telescope concept was developed between 1989 and 1994. Correcting the flawed optics of the Hubble Space Telescope in its first years played a significant role in the birth of the JWST. The combination of technologies required to make the James Webb Space Telescope possible is unique to this time in human history. The mirrors, the sun shield, the cooling system, the image processing, the electromagnetic system, as well as the launch vehicle, this venture is a culmination of decades of work from our engineers and scientists. JWST is primarily intended for near-infrared astronomy, although it can also view orange and red visible light, as well as the mid-infrared region, depending on the instrument. It can detect things up to 100 times fainter than Hubble, as well as objects from considerably earlier in the history of the universe. Being over 6 times larger than the Hubble's 2.4-meter diameter mirror with a 6.5-meter diameter gold-coated beryllium primary mirror, the James Webb Space Telescope weighs just half as much as the Hubble Space Telescope. The mirror contains a gold coating for infrared reflectivity, which is protected by a thin layer of glass. This mirror, composed of 18 hexagonal segments, unfolded after the telescope was launched. JWST is an infrared telescope. Infrared is heat, and the heat emanating from the sun would completely saturate its sensors and make observing the distant past impossible. Hence, it has to avoid light from the sun as much as possible. In order to operate correctly, the dark side of the telescope has to maintain a temperature under -233 degrees Celsius. So it is launched to Lagrange Point 2, where it can turn its back to the sun, moon, and the Earth at all times. In addition to this, JWST carries a sun shield, about the size of a tennis court, on its back like a tortoise to block out the heat from the sun. But blocking heat is just one challenge. It was necessary to design a deployment system that would carry this sensitive tennis court-sized telescope to space. The telescope was carefully folded like a giant origami piece to fit into the fairing of the Ariane 5 rocket. Accidental tears in this fragile film framework during the deployment testing in 2018 caused further delays to the telescope. How JWST was transported. When NASA's James Webb Space Telescope was launched, it went through one of the most harrowing development processes any spacecraft has ever endured. But even before it got on top of its ride to space, Webb had to complete a journey here on Earth, which was roughly a 9,300-kilometer voyage at sea. As a one-of-a-kind machine, Webb required a colossal, specifically designed suitcase known as STARS, STTARS, which stands for Space Telescope Transporter for Air, Road, and Sea. STARS is essentially a mobile cleanroom. When Webb is on the move, STARS maintained a low level of contaminants inside the container. Webb's contamination control team employed several tried-and-true methods to clean both the outside and inside of the container and prepare it for receiving and carrying Webb. Members carefully inspected each screw, nut, and bolt for residual contaminants using ultraviolet light. Planning any trip is hard work. With Webb, added to that are the logistics of transporting an extremely large and incredibly sensitive space telescope across 2 oceans. Due to its sheer size and weight, stars traveled at a speed of only 5 to 10 miles per hour on the road to maintain a smooth ride. The team chose to transport Webb to Kourou by sea due to the logistics of the landing at the Cayenne Airport in French Guiana. Compared to the turbulence of air travel and the forces experienced during landing, traveling by sea aboard the cargo transport ship MN Colibri was quite literally smooth sailing. Webb was shipped from California on 26 September 2021, ultimately passing through the Panama Canal to reach the Port de Paria-Cabo, located on the Kourou River in French Guiana, on the northeastern coast of South America on October 12, 2021. Webb was then driven to its launch site, Europe's spaceport in Kourou, French Guiana, where it underwent 2 months of operational preparations and finally launched on December 25, 2021. Well, after all these efforts and years of hard work, the telescope is now where it needs to be, all set, studying the knowns in detail and discovering the unknowns. What are your thoughts about this amazing journey the James Webb Space Telescope went through? Let us know in the comments section below. Also, if you liked this video, give it a thumbs up. Thanks for watching Space Nomad, and stay tuned for more amazing videos.